right, well, our next lesson, which I believe is lesson 115, we will have our test over chapters 9 and 10. By way of review, chapter 9 was all things imaginary and complex numbers. Okay, so quick refresher for complex numbers. Well, what is a complex number, first of all? Quentin?
A number that's half real, half real, half imaginary.
Part real, part imaginary. And so the standard form of the complex number is what, Jamie?
Oh, it's like a plus bx.
A plus bi, there we go. And then we also had the trigonometric form of the complex number, sometimes called the polar form, but I'll usually say trig or trigonometric form. What was that?
R times cosine theta plus I sine theta.
Does it seem like a long time ago that we were doing that? Yeah, I mean, we know it was only like a week and a half ago, but it feels like a long time because we haven't been using it, and we're not used to that in math, are we? Right? Math, we're used to constantly using what we've been learning, and this really did kind of segment itself, which is one of the things that makes this test a little challenging. Okay, so hopefully the review we're doing now will help to make it less so, help refresh our memory on some things. If I wanted to go from the standard form to the trigonometric form, we would need to remember how to get the r and how to get the theta. How do we go about getting the r value? Jamie?
We'll get the r by, wait, is it the square root of a plus b?
Close. Quentin, help?
Squared.
Squared, right? Remember, it's like the Pythagorean theorem. You got your a along what we used to call the x-axis, but it's the real axis. You got your b going up the imaginary axis, right? So those are the legs of the triangle, and the radius vector is your r, the actual distance to the point. So it's just the Pythagorean theorem. And then what about the theta? We're going to find theta. Let me open some windows and let some natural air conditioning in.
A plus B.
Is it tangent of b over a?
Close. You're finding an angle though, so not tangent. Arctangent. All right, so if only you two could team up on this test, you'd be doing okay. All right. It's a good refresher though, right? So make sure we're kind of getting these review notes down. Now remember, for this, we have to consider the quadrant as well. What if I wanted to go from the trig form back to the standard form? We said this is actually really easy because all you have to do is distribute.
Yeah.
Right now, granted, if it's a special angle, right, instead of cosine 30, we would actually think, well, what is the cosine of 30? Based on our triangles, and or the unit circle if you use that. But yeah, generally we're just distributing back. Let's go back now to the standard form, though, and review some basic operations. So for instance, if I had a 5 plus 2i, and I wanted to add 5 plus 2i to 6 minus 4i. At your seats. And what do I get when I add these together, Quentin?
11 minus 2i.
Good, we end up with 11 negative 2i. We just add the reals and we add the imaginaries together. What if we wanted to subtract 5 plus 2i from, that's an important word by the way, 6 minus 4i. Take you back to your algebra days for a moment there with that from thing. Do you remember from algebra what we need to remember about the word from?
Switch.
The from comes first, right? Now, you say switch, but Quentin, if I'd said from 5 plus 2i, subtract 6 minus 4i, you wouldn't switch, because the from is already first. It's just that it's not first. So here is technically 6 minus 4i minus the 5 plus 2i, but then on top of that, we also remember, we never really subtract, we add the inverse. So we change those signs, and what do we end up with here?
1 minus 6i.
1 negative 6i. Okay? Questions on that? Do we want to do another one like that, or we feel like we've got subtraction? Should be good, okay? Now let's multiply this by this. What do we have to do to multiply standard form complex numbers class?
Well,
FOIL. Yep. First, outer, inner, last. You see nothing. Listen. When we initially FOIL these values, what do we get here, Clinton?
30 minus 8i plus 8i squared.
All right. And then what do we need to do, Jamie?
Oh,
We're not going to leave it like this,
the
remember?
I squared is just negative 1, so it becomes positive 8. And then you'll add that to the 30 to get 38. Negative 8i.
All right. Is this what we had?
Yes.
All right. Questions on this? And then everyone's least favorite, right? If we had to divide this by this, and this was kind of where we led into that talk about the trig form, because division was annoying in the standard form. There's got to be a better way, and there is, but we're going to still be able to do it in the standard form. Jamie, while Quentin's finishing up, when we see a division problem, we should always show it, or typically we'll show it using a
Fraction bar.
fraction bar. And that's going to be advantageous here to show this with a fraction bar. But what's the key to dividing by a complex standard form number, Quentin, now that you're finished?
You have to multiply by the conjugate.
Good, we're going to multiply numerator and denominator by the conjugate of the denominator, which is
6 plus 4i.
6 plus the 4i. So that by multiplying by the conjugate, the denominator is going to become, Jamie,
36 minus 16i squared.
good, a difference of squares, right? We're going to square the first square, the last, put a minus sign between them. And of course, this 36 minus 16i squared, when we remember that I squared is negative 1, we have to make it a positive 16, we end up with what denominator?
52.
52. All right. Then in the numerator, once again, we're going to have to FOIL. I think I actually called on you last time, so I'm going to have Jamie give me the FOIL as well here.
30, negative 8i, negative 3. Right now.
Well, it's a slightly different FOIL than last time because it's
Right.
6 plus 4i now.
42. 32.
32i. There we go.
And 8i squared.
Positive 8i squared. Okay, and then Quentin, now that we've gotten this far, you fix it up for us.
I squared is just negative 1. So that would be negative 8. So 22 plus 32i.
I'm not going to leave it like this, though. Why not? Minus a point.
Everything's divisible by 2.
I can knock a 2 out of everything, right, to get what final answer then.
11 plus 16i all over 26.
There we go. And again, some texts would say that 11 26ths plus 16 26i or plus 8 13ths I would be the best way to write it. I'm fine with that way. Questions on this? Of course, we understand we could split it up if we wanted to. We're just too lazy. All right. Now I want you to take this and convert this to the trig form. We're going to convert this now to the trig form. All right, the first thing we had to find was the R, and what is R, class?
5.4.
Well, we don't do decimals. We usually leave as a radicals.
29.
Yeah, we'll usually leave square root of 29. And of course, we'll have the cosine of theta, but what is theta here, class?
21.8.
Yeah, 21.8 degrees if we round to the nearest tenth, and that's what we usually did, right? Just gave ourselves a decimal place, plus I times the sine of 21.8 degrees, and there would be our answer. What if we had, though, a negative 3 plus 7i? Convert that to the trig form now, if you would, please. What do we get for the r value this time, Quentin? Yeah, and of course we would look to take the root if we could, or at least reduce it, but there's no way you can reduce the square root of 58, so we're going to leave it. And now initially, Jamie, if you just take the b over a, the 7 over 3, and take the arctangent, it doesn't give you a second quadrant angle, so we have to account for that, and what should our angle end up being here?
Maybe 113?
Good, 113.2 degrees if we round off, plus I times the sine of 113.2 degrees. Did we get the 113.2? Again, if you put it in hard and fast, remember, arctangent, you might remember, is limited between negative 90 and 90, going back to last semester. It's going to give you a negative 66. So my suggestion was don't confuse yourself with negatives. Just say 7 to 3, right? And that'll give you a regular 66-degree reference angle. You then say back 3, up 7 puts us in quadrant 2, take 180 minus that 66 point whatever it was, and that's where you get the 113.2. All right, do we need to practice another one of those, or do we think we've got it for tomorrow? We're good to go? All right, obviously if you're watching on YouTube and you want more practice, always let me know that, right? So you have an open invitation anytime you want help to just ask. All right, from there then we mushed over to the trig form, right? And we talked about using the trig form to multiply. We don't have to FOIL. Multiplication is easier in the trig form. For instance, if I had 8 times the cosine of 190 degrees plus I times the sine of 190 degrees, and I wanted to multiply that by 2 times the cosine of 290 degrees plus I times the sine of 290 degrees. Well, really easy initially, at least, to multiply. At your seats, do so. My back seized up over the weekend, so my back muscles are really tight, so I'm just trying to massage the... No, they're done. We're going home.
Question based. Do you want to run the endurance run with us?
On Wednesday? No, I don't.
That's a great idea.
Yeah, we'll see if
I
you
want
can pass
to
it.
see if you
Yeah.
can follow along with me.
I could when I was in junior high, though. I could pass. I couldn't make 100 in junior high, though I might have been able to here. I don't know. But where I was, I couldn't make 8. I never made 8 on my endurance runs in junior high.
Are they tough?
Their standard was a little bit higher, and I wasn't in great shape yet. So, yep. I got in great shape after PE, so it's like, well, fat what a good that did me.
I think I could make it to 90.
All right, when we initially multiply, remember, what do we do with these R values, class? Multiply to get 16, and then what do we do with the theta values, class? We add them to initially get
like 480.
480 degrees. I'm allergic to angles that big. We don't mess with angles that big. What do we do, class?
Is that 360?
Yeah, quick, before I sneeze again, what do we get?
120.
Oh, okay, that feels better. All right, we're good now. Cosine 120 plus I times the sine of 120 degrees. Maybe a little dramatic, but whatever. All right, but we're not going to leave our answer like that. We're going to convert it back to the form that's easier to look at, right? Because that just looks ugly, right? The trig form looks ugly. Standard form looks nice. So when we convert it back, we need to think, first of all, well, 120 is in quadrant and has a reference angle of 60 degrees. So what is the cosine of 60?
1/2.
Yes, 1/2. And in quadrant 2, cosine is negative. Where the sine of 60, and in quadrant 2,
Positive.
and of course don't lose your I. And we'll distribute the 16, and we end up with what answer here, Jamie?
-8 plus AI times 73.
And there we go. Do we get this answer for
I
this
forgot the negative. but-
Forgot the negative, okay. I left it in the trig form here. All right, so just a refresher there then. Let's do a division problem now. And I'm going to change just a little bit here rather than rewrite everything because, you know, lazy. And so let's go with that now. Make sure we convert to the standard form at the end of the problem. Whose name did you see first? Do you remember?
No.
Yeah.
I saw Jamie's first.
I saw 3. I saw Harry's first.
So Jamie's the third.
How are we going over?
Whose name did you see first?
Yeah, she doesn't remember.
So I saw Audrey's.
I thought you said you saw your own first.
Well, besides mine.
Oh,
Let's
okay.
go in order.
Because mine's backwards.
All right, so again, just like we would multiply the r's when we multiply, when we divide class, we
Or what we
divide the r's to get 4, and then we'll subtract the thetas. And when we subtract, we're going to get negative 45. And remember, there's 2 ways to account for the negative 45. One method would be on the cosine, gone. On the sine, pull it out front. But my thought was you could mess yourself up that way. You could lose track of that negative. So my suggestion was, instead of a negative 45, add the 360 to get 315. Either way works as long as you're careful, right? So nothing wrong with the other method other than I could see that being an easy mistake to make. And we like to play mistake-free football. Sorry, we like to do mistake-free testing so we get on the wall of fame. And so here, we're thinking this is quadrant, reference angle.
45.
The Bengals, by the way, played mostly mistake-free football until all of a sudden the refs got flag happy. Now, the last couple flags, admittedly, the Bengals deserved. But that first one, the one on 3rd down that gave them the first down, the holding call, I'm like, not so much a holding call there. That was a no. I should have held him to a field goal. We should have, anyway.
What did the Bengals
Or forced him into that 4th down last gasp chance. And anyway, so I know some Bengals fans blaming the refs for that Super Bowl loss. I blame the Bengals for not being able to keep Joe Burrow standing upright. You know, I mean, gotta have an offensive line if you want to win football. Though the Colts have an offensive line, we just don't have like Jamar Chase, and we don't have weapons. They have weapons, but no O-line. We have O-line and no weapons. It's sad. Anyway, I digress. That has nothing to do with the lesson. All right. So cosine of 45, class. And in quadrant 4,
Positive.
positive. Okay, sine 45.
32.
And in quadrant 4, and don't lose your I. Distribute the to get what, Quentin?
2 times square root 2 minus 2i square root 2.
All right, do we get this answer this time after all that rabbit trail? All right, questions on this? All right. We also talked about de Moivre's theorem, in which we could raise a trig form complex number to a power. And of course, we didn't even do that in the standard form. I showed you how we could use Pascal's triangle to do that, but we're lazy. So I said if we had, for instance, 4 times the cosine 170 plus I times the sine of 170 degrees, and I wanted you to cube that number. We could use de Moivre's theorem to do so. You seem to be staring and not writing. Focuseth, forsooth.
Who likes writing spelling?
I know, so you want to get it over with as quick as you can. Oh, strategery. Oh, well, you don't count. I remember when I was in 3rd grade, for our spelling words, our teacher would do a spelling bonanza. That's what they called it. That was the worst thing ever. You had to copy all your spelling words twice, all your vocab words once, and you had to come up with an original sentence for all your vocab words once.
That would be so fun.
We had something like that for
I
when
love
Miss
writing
Simpson's
original
out. We
sentences.
had like a weird. She has to do a lot of stuff for the vocabulary.
serious?
Like we had to write all twice.
Yeah, that was so if she assigned bonanza for homework, it's like, oh, like, you know, copying the whole thing twice was already bad, but like having to come with that original sentence.
I love that.
But
That's
as a
so
teacher
fun.
now, I'm like, man, that's so helpful because they learn how to use the word. So it's really helpful. It's just, as a student, it's like, no, I don't like that. All right, we're coming back over here now that we're leaving our study hall kids alone. Cubing this expression, and we start by doing what to the 4 class? Cubing it to get 64. What do we do to the angle?
Multiply by the exponent.
Multiply by the exponent, which the exponent here is a 3. So that ends up giving us initially,
Cosine 510.
but I'm not going to write 510 because it'll make me sneeze again. So what do we do with the 510? Minus 360 to get
150.
150. And then we go from there. This is in quadrant,
2.
reference angle,
30.
and we know the cosine of 30.
Square root of 0.
And in quadrant 2,
Negative.
Jamie, feel free to jump in anytime. The sine of 30, 1/2, and in quadrant 2.
Positive.
And of course, don't lose your,
I.
and then we need to
Distribute.
64 to get,
Negative 32 square root of 30 plus 32.
and there we go. Did we have this answer? All right, so we're remembering all of this now. Now it's not start seeming like quite as long ago now. All right, and the last thing we did with de Moivre's theorem, remember, was we used it to find roots. All the roots that in algebra 2 you couldn't find. I told you one day you would find them. So I want the sixth roots of 64. Remember the key? Fractional exponents as you reuse de Moivre's theorem. just a little bit longer to be finishing. All right, so for starters, we're going to write 64, and we're going to write the sixth root, but instead of the sixth root, I said we're going to write it as a power, which would be the 1/6 power, but I'm going to write my 64 as 64 times 1, but the 1 is actually going to look like what?
Cosine 0 plus I sin 0.
All right, we'll forego the Valentine's Day jokes. And then from there, remember, if we want all 6 sixth roots, then we'll have to do this 6 times. So 0 degrees, then we're going to do it again, but we're going to write our 0 degree angle as 360 degrees, and then as, and then we're going to write as 3 more things, so we've got 6 of them, right? We're just too lazy to do all of that. So then, we're actually going to, like de Moivre's theorem calls for, raise to the power. And 64 to the 1/6 is actually going to give us our principal root, 2. And it's going to do that every single time we do it, obviously. And then, according to de Moivre's theorem, we're going to raise or multiply the angle by the exponent. In this case, 0 times a 6th gives 0. And then the next time we do it, it's going to be 360 times a 6th, which is going to give us 60 degrees. And then 720 times a 6th.
120.
And by now we should be seeing the numeric pattern. Of course, we're going in increments of 60. So my next angle is going to be 180 plus I sine 180. And then 240 plus I sine 240. And then
300.
remember, if you accidentally were just having so much fun going by 60, you lost track of yourself, it would catch it itself because the next angle would be 360. Also, you're not weird, so you wouldn't have so much fun, you'd keep going. You're looking for the first opportunity to call it quits without looking like a slob. All right, so of course the first one, cosine 0 plus I sin 0, we already said that's 1, 2 times 1 is just 2. And of course we're going to get that principal root. Here, the cosine of 60 class, and the sine of 60, and we don't lose the I, and we distribute the 2 to get, Quentin?
1 plus square root of 3 I.
Or rather, remember we'll put the letter before the radical, they're 1 plus I squared 3. For this next one, the reference angle here, class, is 60. So it's going to be the same values, 1 and I squared 3. But, because 120 is in quadrant 2, cosine is going to give us a, and sine is going to give us a positive. We should remember that if cosine 0 plus I sine 0 is 1, then cosine 180 plus I sine 180 is going to be negative 1. It's going to be the opposite. So 2 times negative 1 just gives us negative 2. And that's the other root we could have found back in algebra 2. Here, 240 has a reference angle of, so once again, it's going to be a 1, and it's going to be an I squared of 3. But because we're in quadrant 3, cosine is, and sine is negative for both of them. And then 300 also has a reference angle of 60. So again, it's going to be a 1 and an I squared of 3. Does it always work that way for all of these? No, but this one happens to. And so we know in quadrant 4, cosine is going to be
Positive.
and sine is going to be negative. And there are the 6 sixth roots. Did you get all 6 of them? Do we feel confident we're going to be able to do this? Now again, the only time it'd be weird is if it was like a 5th root. Because your increments are 72 degrees apart. That's not special, right? That's going to be a little harder. But I mean, square roots would be 0 and 180, right? Cube roots would be 120s going around. 4th roots would be 90s going around. 6th roots, we have 60s going around. 7th roots would just be ugly. We're not going to do that to you. 8th roots would be 45s going around. So a lot of these would give you special angles. I guess 9th roots would be kind of weird, right? Because we'd go around in how many degree increments? 40 degree increments. So 40 is not special, 80 is not special, but 120 is. 160 is not, 220 is not, 260 is not, 300 is. I got off somehow. I'm going with 40-degree increments. Where did I go wrong? 120, 160, 200. 200 isn't, 240 is, 280 is not, 320 is not, and then of course we'd be back around to 360. So a couple of them would be special, and a couple of them we'd have to use the calculator to distribute. So I mean, if, for instance, we had something like, you know, I don't know, 3 times the cosine of 100 plus I sine 100 or something. And it's not a special angle. We just distribute on the calculator. And usually we give ourselves a couple of decimal places on a distribution like this. Make sure we're in degree mode, of course.
Negative 0.52.
And of course, we wouldn't want to lose our I, right? So if we did happen to come up with one that wasn't special, we could distribute like that. It's a little less satisfactory because it's only approximately equal to that, whereas this is exactly equal. But, you know, whatever. I think we can get over it pretty quickly. Questions on that? All right. That was chapter 9. Any chapter 9 questions? That's pretty much what it was. I mean, I suppose things I hadn't reviewed yet, like powers of I, like I to the first, of course, is I squared is, we have reviewed that, I cubed, negative I, just put those two together, and then I to the fourth is, remember all 4 i's are 1, so if we had like I to the 17th, well, how many 4 i's are in there? 4. 4, so that takes care of how many i's? 16. That only leaves us 1 left, so that's just I, right? And we remember doing that? Questions on any of that? All right, any questions? Chapter 9. Chapter 10, we begin analytic geometry. Of course, this is Valentine's Day, so we can think back to that beautiful love story, and then move on again. And because that's not going to be on the test. But, you know, kind of interesting fact to know, and corny at the same time. We began talking about analyzing equations, and there were 3 basic analytic tools we used.
Intercepts.
Symmetry.
Domain.
Good. Hey, see, look at that tandem. Look, see, it's just beautiful, beautiful. Intercept, symmetry, domain, and range. And for intercepts, the key is you plug in
0.
zeros. The key for symmetry, plug in.
Negative.
And for domain and range, you're actually going to solve the equation. And the key is you always do it for the other letter, right? So selfless love. This is a beautiful illustration. So if we had a 2x plus 5y squared is equal to 20. Well, what shape, first of all, are we anticipating here? A parabola, right? One squared, one isn't. But if we wanted to find the x intercepts, well, at your seats, go ahead and find those intercepts. My Algebra 1 students just recently learned how to find intercepts. Pretty big day. They're not paying attention. It's okay. And to find the x-intercept, class, we said we plug in 0 for y, and when we do, we end up with x is
20. Oh, that's a 20. I put 2 on my
10. X is 10. All right, plug in 0 for y, 2x equals 20, so x equals 10. All right, y-intercept, plug in 0 for x, and when we do that, we're going to have to divide by 5 and then take the square root to get positive negative 2. So we have a couple y-intercepts, just the one x-intercept. All right, at your seats, analyze for symmetry. Remember, to find out if we have x-axis symmetry, we got to plug in. Can I put a negative where the y is and it stays the same? Yeah, because it's being squared. So x-axis symmetry, answer is yes. What you see above the x, what you see below the x is going to be mirrored. Y-axis symmetry, we plug in negative for the x, but that's going to mess things up. So no, we're not going to see symmetry side to side opposite the y-axis. Origin symmetry, negative for both. If I plug in a negative here that doesn't change, plug in a negative here that does change, and that doesn't even get touched. No origin symmetry here. So only above and below the x-axis is going to be symmetric. Finally, domain and range. Add your seats. All right, domain, all possible x values. So to see what x values you can plug in, my suggestion was set the equation equal to y. When I set it equal to y, of course I'm going to have to move the 2x, divide the 5, take the square root. So I'm going to get y is equal to... There we go, technically positive, negative, but who cares about that, right? As we look at the x, thoughts on what's that critical number for x that would just work? 10. You plug in a 10 right here, that's going to give you a 20 minus 20 is 0. 0 divided by 5 is 0. You can just take the square root of 0. Can I use bigger values than 10, or do I have to use smaller values than 10?
Smaller.
I've got to go smaller than 10. 9, 8, 7, 6. Those are all fine. Negatives are fine. But you go any bigger than 10, you're in trouble, right? So, what's my domain? Negative infinity up to 10, but no bigger. All right, do we have that for the domain?
I got confused. I didn't have negative thing. I just had like from negative 10 to 10.
Okay, does that make sense?
Yes.
All right. And then for the range, that's all possible?
Y value.
Y value, so we're going to set the equation equal to x. And that's pretty straightforward. We're going to subtract away the 5y squared, divide it all the way by 2. But there's no limiting factors, are there? There's no variables in the denominator. There's no square roots. There's no trig functions. So my range is all real numbers. We can have anything for the range. So if we were to sketch this then, of course the easiest, best thing to start with would be our x and y intercepts, right? Start by plotting those intercepts. We had an x-intercept here at 10. We got y-intercepts at positive negative 2. We already kind of know it's going to be a parabola, but in case we didn't, no symmetry here, no symmetry here, but yes, symmetry above and below. So what you see below is what you're going to see above. We also know range is going to continue spreading outward, but the domain is only going to come from negative infinity up to this point. So in case we hadn't figured out this basic shape, that hopefully looks better than that. There we go, ish, plus or minus. Of course, it doesn't really go parallel, so I want to make sure it is still somewhat spreading upward and somewhat spreading downward, not really going parallel here. So all fun things you'd want to make sure of as you graphed it. Questions on this? All right, what about, let's analyze this one now. Y is equal to x cubed, negative x. Y is equal to x cubed, negative x. As you work all the way through. All right, let's take a look here at the x-intercepts. Remember, we're going to plug in a 0 for the y. When we do, we're going to get the x cubed minus x is equal to 0, but I'm going to have to do some factoring, right? And so when I factor here, pulling out the x, leaving us with,
X squared minus 1.
I'm going to have to set the x equal to 0 and the x squared minus 1 equal to 0, where, of course, this just gives me 0. But here, what do I end up with for x? So I end up with actually 3, positive, negative 1. I end up with 3 different x-intercepts. I end up with positive, negative 1, 0, and I end up with 0, 0. So 3 x-intercepts. Did you get all 3?
I see what you're saying.
All right. For the y-intercept, here we just plug in 0 for the x, remember, and this is considerably more straightforward. You plug in 0 for the x's, and we just get y is 0. So just the one y-intercept. What did you get as far as symmetric to the x-axis? What was the verdict when you tried to plug in a negative for the y, class? No. What about negative for the x's, for the y-axis symmetry? No. What about negatives for x's and y's? Yes. Because you plug in a negative y, you plug in a negative x and then cube it. Plug in a negative x here. Well, negative x when you cube it is negative x cubed. Minus a negative x gives a positive x. Do you see that if I just changed the signs of everything, we'd go right back where we were, and we could. So yes, this is a rare no, no, yes type of equation. It is going to be symmetric to the origin, so the third and first quadrants will mirror, second and fourth quadrants will mirror. For the domain, remember we want to set it equal to?
The other.
Right, so since domain is all possible x values, we set it equal to
Y.
which it already is, and we ask ourselves, are there any limiting traits about that? No. So my domain is all real numbers. Now the range is a little bit more tricky, because if I try to find the range, I've got to set it equal to x, but that's going to be harder to do studying while you're dismissed. If I try to set it equal to x, I would perhaps end up taking a cube root, but does a cube root ever limit anything? Even roots limit, so the range is also going to be all real numbers. So if we were to look at the graph here, we've got a positive 1, negative 1, 0 along the x, 0, 0 on the y. We're going to mirror here and here, and we're going to end up getting a graph that looks something like that for a cubic function, remember. And that's one where we might need a little bit more point-by-point plotting to figure out some of those other values, I suppose. Well, what if x is 2? Well, if x is 2, then y would end up equaling 6. If x is negative 2, y is negative 6. So, 2, 6, negative 2, negative 6. Maybe that helps us to get that curved pattern. But questions on this? All right. Now, if you're watching on YouTube, I already went over the quiz from the last lesson with them. That reviewed points of intersection and parametric equations. Okay, so we're not reviewing that here because we already reviewed it. If you needed more help, make sure you've gone over that quiz with me, or I've at least had a chance to see the quiz before you take your test. Test in our next lesson. Only homework is be ready. So study over notes as needed for your next test. Have a wonderful rest of your day. You are dismissed.